Good afternoon and welcome to NASA's Kennedy Space Center in Florida for the SpaceX CRS-11 pre-launch news conference. We're all excited and ready for the launch tomorrow of the 11th Commercial Resupply Services mission to the International Space Station. And here to tell us more about it today, we are pleased to be joined by, to my left, Kirk Shireman, manager of NASA's International Space Station program. Hans Königsmann, SpaceX Vice President of Flight Reliability. Camille Elaine, International Space Station Program Science Office at Johnson Space Center in Houston. And Mike McAleenan, Launch Weather Officer from the U.S. Air Force 45th Weather Squadron. Thank you all for joining us. And we'll be happy to take questions after we start off with opening statements. And Kirk, I'll turn it over to you.
All right, thanks. Good afternoon. It's great to be here with you. Really excited about the launch tomorrow evening, and we're counting on the weather cooperating, but we'll hear more about that in a little bit. Lots of great things associated with this flight. I would like to tell you a few things that we're excited about as an ISS program, and then tell you a couple things about the ISS vehicle. First off, this vehicle, we're going to carry over 1,700 kilograms of pressurized cargo. Largely utilization cargo. For this increment pair, we're going to have 213 different investigations. 130 of those are led by the U.S., and in fact 65 are brand new investigations never conducted on ISS. This vehicle is going to carry up three very unique payloads in the trunk, unpressurized. NICER, which is going to look at neutron stars. ROSA, which is a rollout solar array experiment we're really excited about, and MUSES, which is an external platform for various other payloads to use, and it's also a commercial platform built by Teledyne Brown. Lots of pressurized cargo too. We're going to fly fruit flies. In fact, it's Fruit Fly 2, so it'll be our second time to fly fruit flies. Rodent Research 5, so our fifth time. And I think you heard some more about that earlier today. Protein crystal growth, both CASIS and JAXA both have protein crystal growth experiments going on. So lots of utilization for this flight. And we're very, very excited about doing that. It's going to keep our crews very busy on orbit, and we're looking forward to the results of those investigations. On orbit's been a very, very busy time. We've conducted here, very recently, we've conducted 2 spacewalks, one actually unplanned. We had a failure just a little over a week ago, and a failure occurred Saturday morning, and by Tuesday morning we were out making a repair to a multiplexer, demultiplexer, basically a computer outside, and that was successful. So we're very pleased with that second unplanned spacewalk. We're coming up on a very series of events. The first of which is a Soyuz landing. So we actually have a Soyuz landing on Friday. It's going to land about 9:10 a.m. Central Time, 10:10 I guess Eastern Time. Bringing Thomas Pesquet and Oleg Novitsky home. As you may recall, actually Peggy Whitson flew up on this Soyuz, and we reached an agreement with our Russian partners to keep Peggy Whitson on orbit an additional 3 months. And so Peggy will be helping us out on orbit with our complement of 3 crew between when this Soyuz lands on Friday until the next Soyuz launches on July 27th. Peggy and Thomas and Oleg have actually been extraordinary crew members, and we're very happy to, while we can't keep all 3 on orbit, we're very happy to be able to keep Peggy on orbit. As you probably remember, Peggy has the record for U.S. crew members. Actually, I would say the record for non-Russian crew members. Peggy's surpassed Jeff Williams on April 24th with 534 days. By the time she lands in September, she will have over 660 days on orbit. Peggy's conducted 10 spacewalks, which is tied for the most in U.S. history, and she has over 60 hours in spacewalk time with her spacewalk that she had done last week. So tomorrow morning she'll hand over commandership to Fyodor Yurchikhin, but she will continue her great work. And like I said, she'll be supporting this SpaceX 11 flight and incredible amount of work. Just after the crew comes home on Friday, SpaceX will be arriving shortly thereafter, and their first week on orbit, she and Jack Fisher have a tremendously busy week that week just to get all these experiments started. So looking forward to all the great work going on International Space Station, and certainly to the cargo arriving here later this week.
Hans?
Yeah, thank you. So I have a couple items to report on our mission 2. First of all, the targeted launch window is 5:55 p.m. The ascent typically takes 3 minutes for the first stage, and this particular first stage will then separate and come back to LZ1, which is the landing zone down here at the Cape, for a land landing. Second stage will continue to fly for another 7 minutes about, and then deploy Dragon in its nominal orbit. The Dragon itself will fly about a little less than 3 days before it docks to the station, and then it will remain on the station for about a month after launch. There's a couple interesting things here. One of them is this is the 100th launch from the LC-39A launch pad, if we counted correctly. Which I hope we did. And then this particular Dragon is a refurbished Dragon. It has flown previously on CRS-4, which is about little over 2.5 years ago. I think it was September, October in 2014. And we, once this capsule landed, we refurbished it, inspected it, made sure everything is qualified for the next flight, and this is where we are now, ready to go on 39A. For us, it's the 7th launch this year. You can tell that we picked up the rate significantly. We are hoping to stay at this rate through the rest of the year and work our backlog down, basically. We are hoping to also fly more and more Dragon refurbished, and the same is true for the first stages. As you know, the next launch after this is also refurbished first stage, for example. And with that, I do want to thank the Falcon 9 team for getting this Falcon 9 ready, the Dragon team for getting the Dragon ready, and the launch team for working really, really hard to get these launches scheduled within 2 weeks from each other. Not last but least, 45th Space Wing and FAA for their support, and then, of course, NASA for the opportunity to deliver cargo to the space station. Thank you.
Thanks, Hans. Camille?
Thank you, Mike. Good afternoon. It's really a pleasure to be here to share some of the science that's going up tomorrow on the CRS-11. We're excited to have about 4,500 pounds, as Kurt said, of research supplies and science investigations, including about 2,000 pounds of the unpressurized cargo, the 3 instruments that are flying in the trunk of the Dragon capsule. We are also excited because the Dragon has the capability of returning samples back down to Earth, and so it will return about 1,500 pounds in about 30 days on its return. These experiments are supporting about 220 investigations currently going on during increment 51, 52 on board the space station. And they span a multitude of scientific disciplines, including biological research, the physical sciences, the human research that we're doing with the astronauts, the technology demonstration, studying Earth and space from the ISS, and then last but not least, the educational activities that students have an opportunity to participate in. So earlier today, we had the What's on Board briefing, and there was a sampling of some highlights from some of our principal investigators that will be flying their payloads tomorrow. That includes some of the mouse models that will be treated with this novel therapeutic drug called NEL-1 that is known to have the ability to not only prevent bone loss, but also to promote bone formation. We're also flying thousands of fruit flies that will be used as models to study the cardiovascular changes that happen in long-duration space flight. So these scientists will be looking at how the heart, the cardiac function, the cardiac structure, and the cardiac gene expression of these flies adapt to space flight. And that will be an analog for how human heart operates in spaceflight environment. We also have the 3 external payloads I mentioned earlier, an Earth viewing platform developed by Teledyne Brown called MUSES, and that has the ability to house up to 4 Earth sensing instruments, including hyperspectral imagers and high-resolution digital cameras. It has the ability also to provide instruments with pointing accuracy and other accommodations such as data and power. We have the NASA Astrophysics Experiment, which is the neutron star interior composition explorer that's going to be measuring the dynamics, the structure, and the energetics of neutron stars. And it's also going to demonstrate a technology that would be using pulsars as a navigation beacon for interplanetary spacecraft. And then we have the Rollout solar array, or ROSA, which demonstrates, actually tests the deployment and retraction of this new type of lightweight solar array system. They will be looking at some of the energetics, the dynamics of this solar array once it's deployed in orbit, and how the thermal differentials in space, the space environment, affects this solar array system. Then we have some physical sciences experiments, specifically one by Procter & Gamble, which is studying some colloidal gels and creams, which are consumer products. And they are looking at how the environment of space, microgravity, impacts these colloids, how they behave, and ultimately wanting to increase the shelf life of these gels and creams. And lastly, we are flying some CUBE satellites, a constellation of 5 CUBE satellites, which is a part of a multi-nation project called the BIRDS Project. And these CUBE satellites were developed by students from Japan, Nigeria, Ghana, Indonesia, Thailand, and Bangladesh. And so they will be using these CUBE satellites to not only measure atmospheric density, but also to measure the exact location, precise location of satellites, and also to demonstrate a network of ground control system operators. And then we have a suite of education experiments by the Valley Christian High School in California in partnership with NanoRacks, and they will be looking at the effects of microgravity on various things from brine shrimp to magnetoreological fluids. They'll also be looking at the growth of probiotics in space versus how those are grown on the ground. They'll be looking at how water crystallizes in space versus how it crystallizes on the ground, and the effects of microgravity on this nutrient solution called BAM-FX. So that's just a sampling of some of the science that will be enabled by tomorrow's SpaceX launch that contribute to not only the advancement of human space exploration, but also improving the quality of our lives here on Earth. Thank you.
Thanks, Camille. Mike.
All right, well, welcome to Central Florida's convective season, which started yesterday. It might help out the fires a little bit, but it makes afternoon launch windows very sporty for the next 3 months. The Space Coast's daily barrage of thunderstorms is triggered largely by the sea breeze, which wants to move inland, but can be helped or hindered by the low-level flow. The last 2 days, we've had low-level flow out of the southwest, which pins the sea breeze very close to the spaceport, and hence we had the afternoon thunderstorms here. Guidance is suggesting that this flow switches a little bit tomorrow and more southerly, which will allow the sea breeze to move inland a little bit quicker. I still think we're going to get thunderstorms. I still think we might even see a couple during the countdown, but there's a decent chance that we're going to have that thunderstorm and the sea breeze far enough inland between 4 and 6 p.m. that we have a good shot of getting the launch out of here. So let's look at the forecast. For tomorrow, we got winds basically 110 degrees, 12 to 17 miles an hour. And they're going to switch around easterly every single day, but it's that before the sea breeze kicks in is literally what drives how far it'll move. Temperature's going to be warm again, 84 degrees. And our main concern is the anvil cloud rule. Even if the thunderstorms move inland, our upper level winds are out of the northwest. That could bring the anvil clouds back towards the Space Coast. We have the rules are very good at giving us some opportunities that are safe to launch. So I think the anvils that'll be overhead will be thin enough and high enough that we can get through those. It'll be lingering cumulus clouds that if the sea breeze doesn't quite move in far enough, that would also be a threat. So a 30% chance right now of violation. If we were to move to the backup day, which is Saturday, weather degrades a bit. We have the low-level flow back to the southwest as the Bermuda Ridge axis slides back to the south. That should pin the sea breeze a bit closer to us and also the thunderstorm activity. So a little bit worse case, still fighting the anvil clouds, even if it moves inland. But I think we're adding the flight through precipitation rule for the Dragon capsule. We may have our own activity very close to the doorstep. So 40% chance of violation if we were to go Saturday. So overall, we've got a shot. It's not a slam dunk, but there's an opportunity that we will get between the two rounds of thunderstorms if we are able to get in there tomorrow. Thanks.
Okay, thank you, Mike. And we're now happy to take questions. Before we take any in the room, I just wanted to announce, though, that if you are not lucky enough to be in the room today, you can ask questions via social media using the hashtag AskNASA. Emily from NASA Social is here, and she'll be happy to field the questions and pass them on to our presenters. If you are in the room, please raise your hand, let us know you have a question. Please wait for the microphone, state your name and affiliation, and to whom you're addressing your question. And we'll start off over here with Irene.
Thanks. Hi, I'm Irene Klotz with Reuters. I have a couple questions for Kirk. The MDN failure, do you have any insights into what happened with such a new piece of equipment? And do you are you planning on returning that on the Dragon?
So the computer that failed is actually not new. As you probably have heard, we put it outside again with a new an up-to-date processor card, but the box itself actually had been outside since 2014. So we brought it in, we put the card in, we took it back out, and so which is still relatively new, by the way. The computer should still function. We don't know the signature it wasn't communicating. We did see some current draw. We have a fault tree, so we have ideas of what it might be, but we probably won't be able to tell until we bring it home. We're going to take off the cover, do an inspection, and then we'll bring it home, most likely on Dragon when it comes back, and then we'll find out. We've had about 4 computer failures over the life of the program, and they've been different things. The most common is a power supply, which is one of the items, but we won't know for sure. The real point is all these cards that are on that computer, actually identical copies of those are in other places and have had good life on orbit. So we don't think this is a generic problem. We think there's something unusual about this one, and it may have been a component that was 4 or 5 years old.
Okay, thank you. And the other question is about the previously flown Dragon. Did NASA ask for or did you receive any kind of financial discount or any other trade for using that, or was it just a savings for SpaceX to not have to manufacture another capsule? Well,
first of all, this whole notion of reuse is something that's very, very important to the entire space industry, NASA as well as SpaceX and others. And it's not actually a new issue. We've flown things, shuttles flew many times, so the idea of reuse is important for economic reasons as well as technical reasons. Our contract with SpaceX, there are a lot of, it's a fixed price contract, but there are things that change on our side, there's things that change on SpaceX, and we have equitable adjustments on both sides. So yes, if you ask me what it was, and specifically, I'd be hard pressed to quote that to you now. But in general, when we do these things like this, we make trades. Supporting the Dragon reflight is a really, really important step. We went through, SpaceX did a very thorough job in terms of certification of the Dragon and refurbing it, and NASA did a very thorough job of understanding that certification and making sure that it was safe to fly, and the risk was actually not substantially more than a brand new Dragon capsule. So we're very happy with this capsule flying again. We've actually been flying hardware, not whole capsules, but other hardware before, and we expect to increase the amount of reflight as CRS-1 and then ultimately CRS-2 proceed.
Marcia.
Marcia Dunn, Associated Press for Hans. Along the reused Dragon, what did you do in particular? What did you swap out? How much of this is original, so to speak? And will the next Dragon going to space station also be a reused version?
Yeah, thanks for the question. It's the majority of the components on Dragon, and in particular, the most important part is actually the hull. The structure itself is the same as flew the first time. So when Dragon came in the first time, basically we inspect the components. We then compare the loads that they saw, compare this to the qualification, and that tells us how much life a component has, and we make sure that the component has the enough life for the next round, and there's statistical variation, so you have to make a worst case assumption basically to be on the safe side, and that is very similar to what we actually do on the booster. It's not that different. It's a similar situation. When we go through all the components, basically, we make sure that it has enough life. We share the results with NASA and review them basically together, and then we conclude that we can either fly a component, or in some cases we have to make a swap with a new component in some very few cases. But I can tell you the majority of this Dragon has been in space before and has been docked to the station for a couple of weeks.
And, is the next Dragon going to be
Oh,
brand
yes.
new or reused? And also, what did you replace on this one?
The next Dragon, from what I remember right now off the top of my head, is a new one. Parts that we replaced. I believe some of the parts that were on the outside, the batteries, for example, that see seawater and things like that, although they are protected against it, there's several reasons why we might exchange certain things. But again, thruster, harnessing, a lot of that stuff is from the original Dragon.
James?
You really covered my, thanks, James Dean Florida today, kind of covered my Dragon questions, I think. But, the thrusters you say are reused as well?
Yes.
Heat shield, of course, would be something you have to fully replace?
The heat shield is a new one, you're right there.
Yeah,
Mhm.
okay. So the hull, thrusters
Mhm.
are the main components that you would be interested in as far as major components that haven't been reused before?
Let's see. There was the entire plumbing, tanks.
Most of the avionics, right?
There's some avionics. I don't think it's most of it. Depends on where it was. So some of the avionics is from previous flights. I don't have the entire list in my head, unfortunately.
Are you anticipating reusing Dragons for crew flight as well? Is this sort of a precursor to that, or are they totally unrelated?
That is something we need to discuss once we get Crew Dragon flying. No update currently. It's still the end of this year for Demo 1.
Okay, we're going to come over here and take a couple of questions, and then Stephen will come back to you, and Ken. Jason.
Jason Ryan with Spaceflight Insider. This one's for Hans. First question is, Hans, will we see the payload fairing come back under parachutes for this mission? And the second question, I guess, would be is, you guys are flying a lot of Falcon 9s. Can we expect to start seeing a lot more of those being reused Falcon 9s? And if so, what does that mean for your production facilities? Will you kind of slow down the amount of Falcon 9s you're producing and start using the flown ones more and more? Can you tell us a little bit about that? Thank you.
Sure. So first on the fairing, I mean, this is not a fairing mission. This is Dragon mission. So you won't see fairing recovery on this mission, of course. But as you pointed out, on the last 2 missions, I believe, we had, the last mission and the 3 earlier, we had fairings that had the ability to stabilize in orbit and keep attitude, and they had a parafoil on board too. And we got them as far as to deploy the parafoil and to land basically in one piece, although the fairing did suffer some damage by the landing itself. There's still work that needs to be done in order to get the fairings back in a state that we can reuse them again. But I would say we made the first steps, and we have been on those first 2 attempts pretty successful, from what I can tell. I'm not sure how long it will take until we refly fairings, but I would expect this to take some time, similar to the first stage. Then your question regarding the first stage production. We still have to produce the second stage, of course, but we see a shift that we need more second stages than first stages. We've flown 1 booster so far. We have the second pre-flown booster coming up here after this mission very shortly. And so my gut feeling is we will have a couple more this year that will demonstrate on the capability of reflying a booster more than once, hopefully 2.
When do you see that we could actually be at a point where we will see more reflown boosters as opposed to new boosters flying, if you had to guess?
That is an excellent problem to have. I would have to guess, and I don't think it would be a very qualified guess, maybe sometime next year or something.
Okay, Emily has been following social media questions on the hashtag #AskNASA. Emily, have you got any questions for us?
Yeah, we have a couple. This first one's from Gary Walters, and he wants to know, if weather does scrub the first 2 launch windows, does the range allow additional openings in the coming week, and when?
We have no range people here.
Yes.
Yeah.
Typically, typically you're allowed to get 2 days on the range, so there has to be cooperation and conversation between FAA, SpaceX, and the range to make it happen. So there's no question we're going to fly again. If you're asking what day, that might be in question. So without the right people here, it's hard to answer.
And the range works very hard to make this possible. Always did.
All right, this second one, it's a science question from Rome Strach, and he wants to know, what ambient temperature is the pressurized portion of Dragon kept for the rodents and fruit flies, or are the temperatures maintained locally?
So they are in the cold bags, and they are at minus 37 degrees Celsius, I believe.
The rodents on the way, are you asking
Oh,
for
no.
the question on the way up? So they're probably not at minus 37
No.
on the way up. They aren't very
The
happy.
rodents, or okay. So the rodents are in their habitat at room temperature, really, and the fruit flies are also packed in the cool bags to keep them safe.
Okay, Stephen.
Stephen Young with spaceflightnow.com for Kirk. Could you say where NASA is as far as getting comfortable with possibly flying cargo on a reused Falcon 9?
Sure, we're working on it now. We want to be very methodical about it. As you know, SpaceX is certifying the Falcon 9 for multiple flights. We want to take our time and review all those certification results. The other critical thing that Hans touched on is that's all done pre-flight, and then it consumes a life when it flies, and you want to make sure that the life it consumed is actually within the certification limits. And if it's not, then you either replace those parts that are sensitive to that, or you enhance your certification, expand the envelope, if you will. So we're working with SpaceX right now, working on all those things that we'd like to see and actually seeing those results. So I can't tell you exactly when we will see a reflight, but we're working with SpaceX on the potential of reusing a Falcon 9 for a cargo flight.
Okay, in the front row here.
Sawyer Rosenstein with Talking Space. For Hans, a few questions. One, with the CRS-1 contract nearing its end, are there plans to keep building more Dragon capsules for that, or is there a possibility of reusing all of those? And the other thing you mentioned was that it was kind of like the first stage booster returning. Do you know about how much this saves you by reflying it as opposed to building from new?
Okay, so on the first question, I'm not sure I have a really good answer for you because I know that, so you said CS1 and there's the second contract is called CS2, and in total it's 20 flights, I believe, and we are just over the halfway point here with 11. And there's one more capsule right now that's been built. So it depends a little bit. I think we can do the rest with the reused capsule, but I'm actually not sure if that is the exact plan or not. So I have to pass on that a little bit. And regarding the booster and the money you save and these things, this is a little bit more complicated because we did invest in the technology and we invested basically a lot of money on our side to perform tests. If you recall, the first missions were pretty traumatic and spectacular, but largely unsuccessful before we turned it around. And then, of course, these things cost money and damage needs to be repaired. And so I want to basically say we invested a significant amount of money that we need to recover over the next couple of missions before, in my opinion, we can reach out and make that assessment and then actually pass this on really. This is a long-term goal. This is not something that works the second time or the third time. I think this is something that you need to look at a couple of years in advance. Maybe the 10th flight, maybe the 20th flight. That's when you finally could see some money saved.
Okay, we have 3 questions in the front row over here, and we'll start off with Phil.
Hi, Hans. Guten Abend. Phil Keating with Fox News. Going back to the demo. So end of year on a demo, that would be an unmanned Crew Dragon going up to
That's
space
correct.
station, and then followed by when would there be actually 2 astronauts on board going up on the first post-demo mission?
Correct. Demo 2, what you're referring to, is currently planned at the end of the first quarter in 2018.
That would be 2 people on board?
I believe that is 2 astronauts on board, yes. Mhm.
And then possibly, if everything goes as well as expected, then next summer you get a full load?
That is to be seen then what the schedule says further on. My specialty is honestly this particular Dragon we have here, the Cargo Dragon, and the and in particular Falcon 9. So I'm not that, and I don't look that far in the future, anyways.
I'm sorry. Well, you're the only SpaceX person
True,
here, so I've
yeah,
got to ask this
true.
additional question, which is on the recently discussed SpaceX plan to take 2 space tourists around the moon and back by the end of next year.
Yeah.
Can you expand on any of that? Is that still on schedule? Do you know if there's a long list of people applying?
I can only refer you to our media team in the back on those topics.
And will this be the 3rd time it lands on land here?
No, I thought it's the 4th time. It's the 5th time. It's the 5th time we land on land here. I don't know off the top of my head all the missions there, but I certainly believe that that's the case. And then we had 6 launches 6 landings on the drone ship here. So in total, today with 4 land landings and 6 drone ship landings, we recovered 10 booster. That's a lot of boosters.
Chris Gebhardt with NASA Spaceflight for a couple of questions for tomorrow. With Inmarsat, there was an abbreviated fueling with the liquid oxygen. Are we going to see that abbreviated fueling again tomorrow, or normal fueling? And with launch weather, is launch weather the same as landing weather? And the root of my question there is, if you're good to go on launch weather, but if landing weather isn't okay, would you launch and expend the booster instead of delaying?
So, so to your first question, the difference in loading is a bare 10 minutes. It's not a lot. And this, in order to do that, you need to have a hardware change on the vehicle. Inmarsat had that hardware change on the second stage. This vehicle and the next vehicle do not have that hardware change, but the vehicle after that will have that hardware change, and all vehicles after that have that. So it's like, and it has to do more with the timing when the stages were produced than anything else. It just happened to be that the Inmarsat stage was produced after the other two stages. And so that's why this seems out of order, but it actually makes sense when you know the production schedule. Regarding your second question, sorry, what was that again? Oh, yeah, landing better. So I want to say the launch weather is largely also a safety risk thing. And I do think it covers essentially the landing zone too from a public risk perspective. There's weather elements where we can more higher loads, like on wind, for example, you could take more risk on the landing than on launch, for example. And frequently for some of these landings, we had cases where the landing wind was higher than the launch wind. But we would, so far, the launch weather drives the launch availability. Yeah.
Ken.
Hi, thank you for doing this, and good luck tomorrow, first of all. Ken Kramer, Universe Today. My question is for Hans. Two questions. One, can you give us an update on the Pad 40 repairs, and when do you expect to resume, when do you hope to resume launches? And the other one is about one of the science experiments. You are bringing up the ROSA solar array, and then at the end of the mission, you're going to be bringing it back. My understanding from speaking to the team is that you are going to deploy this somehow in space, and I wonder if you could talk about this. I think this might be the first time you dispose of an unpressurized cargo, but anyway, review the procedure, how you're going to do that. Thanks.
You want to go ahead? Okay. So on Pad 40, we actually drove by on the way up here and took a look. So it's very active right now. There's lots of construction going on, and I can see the progress from last time when I was here. Definitely, lots of tubing being welded and big construction machinery moving around. I'm anticipating a later summer, return to operation there. And we haven't really settled on what particular flight is going to go from there first, but the current schedule says this is late summer, early fall we're going to reopen LC 40 again, and then we're going to be able to launch from both 39 and 40.
Okay, we'll take two more questions.
And Rosa.
Oh, I apologize. Go ahead.
So, yeah, the solar array. So it's going to be deployed in space, and it will stay there for the length of the Dragon. It will be put back in the trunk and then disposed of when the trunk is re-entering Earth's atmosphere. So,
can you describe how that will be done? How will that deployment be done?
You want me to take that?
Yeah, sure.
So it actually, we pull it out of the trunk with a robotic arm. We'll hold it in a specific location, and we'll actually deploy it. The array will be deployed. It'll stay deployed for about 7 days. And during that 7 days, a large part of the experiment is actually shaking, vibrating, putting inputs into the array, watching the dynamics, and observing it with sensors and cameras. And then at the end of that 7 days, it'll be retracted and then restowed in the same place that it, actually I shouldn't say the same place, but in the trunk, and then of course the trunk comes in and burns up. This will be actually not the first time we brought something home, this will be the second time. The last flight, SpaceX 10, we brought 3 things home inside the trunk, and of course when we say bring them home, they don't actually survive the reentry environment. So ROSA will not survive the reentry environment when it comes back.
It just sits in the trunk. It's separated and sits in the trunk, and that's how it's destroyed.
Yeah, think of the array unfolds, and then it's retracted, and so it's in I say compact, but it's big. It's the size of this table, and then it's installed back into the trunk, we call it a fram, but a mechanism basically. It's attached, secured there. When Dragon undocks, performs a deorbit burn, and then separates, and the trunk burns up on reentry.
when it's fully unveiled, it's about 12.5 by 5.5 feet. So that's how long it is.
Hi, Thaddeus Cesare with the Utica Phoenix, and for Hans. We've seen the reuse of boosters, capsules. Should see fairing soon. Is there any hints or Anything else coming down the line from SpaceX that we should know in terms of reusability?
So do you what? Say again?
Is there any additional plans for reusability outside of the payloads, the rocket, and the capsule?
I want to say we look at all the aspects of the rocket, and as you may find out, there's the second stage missing in the scheme so far. That's an ambitious goal, but it is something that we should look at the same time too. So I have to be a little bit fuzzy, because this is literally a goal. I would call this.
Okay, and we'll close with a question from Chris.
Chris Gebhardt with NASA Spaceflight again. Exact launch time tomorrow, 5:55, and 51. How many seconds?
51.
51, thank you.
Okay, that's going to do it for today. Thank you all very much for coming. We look forward to the launch tomorrow and the weather cooperating with us, Mike. Our NASA television coverage will begin at 5:15 p.m. Eastern Time for a liftoff at 5:55. And until then, please keep up with all that's happening by going to www.nasa.gov. Thank you very much.